with actual intensity of light, or you can do it with percentages. It doesn't matter. It doesn't matter. It still works the same. So let's just do a problem with percentages here. Okay, just straight percentages, not even having to get to the intensity of light. Percentage of light is able to get through an analyzer, turn 60 degrees to the polarizer. Now remember, the polarizer is the first guy, right? The polarizer is the first guy, and I'm going to butcher this drawing, but we'll do it anyway. So here's my polarizer with, let's say vertical slits. Why not? Okay, and then I'm going to turn my analyzer 60 degrees to that. That's about 45. Something like, it's something like this, right? And now we're going almost, something along those lines. And I'm butchering the drawing, like I said it would. Who cares, right? Here's the polarizer. Here's the analyzer, right? So conceptually, I've got light coming in, right? Of all different, angles, if you will, all different angles and all different planes, every single plane. It goes to this first one. I've got 100% coming through, right? Coming through. It goes to the polarizer. It's cut down to what? 50. Only one plane is allowed to get through. 50. If the polarizer is behaving correctly, yes. Why? Yes. It is eliminating, and this was the explanation that I think I was working on at the end of class, but the bell rang on us. What's happening here with the polarizer? Let me just take a few light oscillating. Let me just take a few directions. Now, obviously, inside of this circle, if you will, there are infinite angles to oscillate at, right? And let's only take a few of them. Let's take what I got 4 drawn up here, 4 different ways it could oscillate. Okay, vertically, horizontally, at the 45 to, what's that angle opposite the 45? Yeah, 180 plus 45 gives you 225, right? And the, what's this angle up here in quadrant 2? 135, and down here would be negative 45, right? So here's all these guys. Let's say we run light, it's coming in all through. Let's take the horizontal guy, right? Horizontal slits. That means it's going to get rid of everything that doesn't oscillate horizontally, right? Which automatically means this guy right here, gone, right? He's vertical, can't go through. This guy right here, gold, good to go, right? Good to go. What about those two guys that, on the in-betweens though? Do they go through? Take the components. In other words, this part doesn't make it, but that part does. And this part doesn't, but that part does, right? You take the components of it, right? So in other words, you're getting the x component of every last bit of light there. And seeing how there are only 2 axes to divide things up between, the y-axis and x-axis, we can say pretty great deal of confidence that 50% of all of it goes to the y-axis and 50% of it goes to the x-axis, right? And so if we cut out all of the y-axis, that's going to leave us all of the x-axis, right? And the sum of all the components of the x-axis would be 50% of the line. Make sense? All right, so I got 50% comes through, and now I'm going to turn it at 60 degrees, and I'm going to get something less than that, right? I'm going to only get a component of that. Got it. Right? I'm only going to get a component of what came through. In other words, now I'm going to eliminate, let's say, if I'm thinking about this, now I'm going to eliminate, let's say, the horizontal guy, or at least most of the horizontal guy, and only be left with a little bit of one of the crosses. Okay? Just conceptually. So in other words, I got I equals, what's I naught here percentage-wise? 50. This is 50%, right? This equation deals with the analyzer. So what goes into I naught here is almost always 50%. Okay, almost always, in fact, it is always 50% of what went through the polarizer. Okay, cut it in half.
That's one of those things that you should never take out for
Yeah, nothing's perfect, but our polarizers, especially with depending on what you're doing, the polarizer can be so good, right, that with the number of sig days that you're going to be able to record experiments like cutting it in half is beyond, figuring out that it's actually going to take out 49.99998%, unless you're doing something really, really, really precise.
always be above 50 though, because you'll leave like other layers than the one infinitely thin one in the middle.
Yes.
Maybe take more. So
Yeah, if it only cuts out 49.99999, whatever, then that's like 50.00001. Yeah. Okay, but it's so small that 50, right, for all practical purposes. Cosine squared of my angle, 60, and this is in degrees. Make sure your calculator's in degrees. So just punch that in. And here's the thing, you can leave it as 50. Your answer, cosine of the theta, comes out to be a decimal. Cosine squared of theta comes out to be a decimal number, and it is unitless. Okay? Whenever you take a cosine or a sine or some trig function of an angle, it comes out to be a multiplier, a scalar number with no units. Unitless scalar that's just a multiplier. So cosine of 60 degrees, square it times 50, I equals. Can't it? Why is the cosine of 60 negative? You have it in radians or degrees? Radians? Do I want radians?
well, even if we're using degrees here,
Should be possible. Change calculator to degrees. Change it to degrees. You gotta have degrees. Because 60 radians is very, very different than 60 degrees. And think about it. An entire circle is 2 pi, right? And that's somewhere a little over 6, right? So an entire circle is a little over 6 radians. All right. Now think about 60 of them, right? That's a long way around the range apparently, and somewhere around quadrant 4 quadrant. Quadrant 4 quadrant. I'm drawing one of those signs. Actually, excuse me, quadrant 3 quadrant 2. There's landing somewhere in there. So what did I come out to be? 4.5% is what it came out to be. Is that right? 12.5. Oh boy. 12.5%, right? This is not a linear function. It's not just 60% of, 50, right? You can't multiply your 50 times 0.4 and get that here. It's cosine squared. It's a cosine function, which automatically means it's not just some linear idea. And then it's cosine squared, which makes it even less linear. Right, as you turn them, right, here's at 45, right, it's not exactly half, right, I mean, and whenever you get all the way over to 60, I mean, it's pretty dark, I mean, it's pretty dark whenever you start getting close to 60 there, it's cut it down quite a bit, okay.
so these problems always ask for
9 times out of 10, they like percentages. 9 times out of 10, they like percentages. But if they deal with it in terms of actual intensity, right? If they deal with it in terms of actual intensity. By the way, what's the unit for light intensity? Lumen, right? Lumen. If they deal with it actual intensity, who cares? Okay, it works the exact same way. You plug in the numbers and you get it. Any questions for grade 6? You have the homework. Take off.